A data model organizes data elements and standardizes how the data elements relate to one another. Since data elements document real-life people, places and things and the events between them, the data model represents reality. For example, a house has many windows or a cat has 2 eyes. Computers are used for the accounting of these real-life things and events, and therefore the data model is a necessary standard to ensure exact communication between human beings. Data models are often used as an aid to communication between the business people defining the requirements for a computer system and the technical people defining the design in response to those requirements. They are used to show the data needed and created by business processes. Precise accounting and communication is a large expense, and organizations traditionally paid the cost by having employees translate between themselves on an ad hoc basis. In critical situations such as air travel, healthcare and finance, it is becoming commonplace that the accounting and communication must be precise and therefore requires the use of common data models to obviate risk. According to Hoberman, a data model is a wayfinding tool for both business and IT professionals, which uses a set of symbols and text to precisely explain a subset of real information to improve communication within the organization and thereby lead to a more flexible and stable application environment. A data model explicitly determines the structure of data. Data models are specified in a data modeling notation, which is often graphical in form. A data model can be sometimes referred to as a data structure, especially in the context of programming languages. Data models are often complemented by function models, especially in the context of enterprise models. Overview. Managing large quantities of structured and unstructured data is a primary function of information systems. Data models describe the structure, manipulation and integrity aspects of the data stored in data management systems such as relational databases. They typically do not describe unstructured data, such as word processing documents, email messages, pictures, digital audio, and video. The role of data models. The main aim of data models is to support the development of information systems by providing the definition and format of data. According to West and Fowler, if this is done consistently across systems, then compatibility of data can be achieved. If the same data structures are used to store and access data, then different applications can share data. The results of this are indicated above. However, systems and interfaces often cost more than they should to build, operate, and maintain. They may also constrain the business rather than support it. A major cause is that the quality of the data models implemented in systems and interfaces is poor. Business rules, specific to how things are done in a particular place, are often fixed in the structure of a data model. This means that small changes in the way business is conducted lead to large changes in computer systems and interfaces. Entity types are often not identified, or incorrectly identified. This can lead to replication of data, data structure, and functionality, together with the attendant costs of that duplication in development and maintenance. Data models for different systems are arbitrarily different. The result of this is that complex interfaces are required between systems that share data. These interfaces can account for between 25 to 70% of the cost of current systems. Data cannot be shared electronically with customers and suppliers, because the structure and meaning of data has not been standardized. For example, engineering design data and drawings for process plant are still sometimes exchanged on paper. The reason for these problems is a lack of standards that will ensure that data models will both meet business needs and be consistent. According to Hoberman, a data model is a wayfinding tool for both business and IT professionals, which uses a set of symbols and text to precisely explain a subset of real information to improve communication within the organization and thereby lead to a more flexible and stable application environment. 2. A data model explicitly determines the structure of data or structured data. Typical applications of data models include database models, design of information systems, and enabling exchange of data. Usually data models are specified in a data modeling language. 3. Communication and precision are the two key benefits that make a data model important to applications that use and exchange data. A data model is the medium which projects team members from different backgrounds and with different levels of experience can communicate with one another. Precision means that the terms and rules on a data model can be interpreted only one way and are not ambiguous. 2. A data model can be sometimes referred to as a data structure, especially in the context of programming languages. Data models are often complemented by function models, especially in the context of enterprise models. 3 perspectives. A data model instance may be one of 3 kinds according to Untitled in 1975. Conceptual data model describes the semantics of a domain, being the scope of the model. For example, it may be a model of the interest area of an organization or industry. This consists of entity classes, representing kinds of things of significance in the domain, and relationship assertions about associations between pairs of entity classes. A conceptual schema specifies the kinds of facts or propositions that can be expressed using the model. In that sense, it defines the allowed expressions in an artificial language, with a scope that is limited by the scope of the model. The use of conceptual schema has evolved to become a powerful communication tool with business users. Often called a subject area model or high-level data model, this model is used to communicate core data concepts, rules, and definitions to a business user as a part of an overall application development or enterprise initiative. The number of objects should be very small and focused on key concepts. Try to limit this model to one page, although for extremely large organizations or complex projects, the model might span 2 or more pages. Logical data model describes the semantics, as represented by a particular data manipulation technology. This consists of descriptions of tables and columns, object-oriented classes, and XML tags, among other things. The logical data model captures the detailed business solution. The logical data model looks the same regardless of whether we are implementing in MongoDB or Oracle. Physical data model describes the physical means by which data are stored. This is concerned with partitions, CPUs, tablespaces, and the like. The physical data model is the detailed technical solution. This is the first time we are actually concerning ourselves with technology and technology issues such as performance, storage, and security. The significance of this approach, according to Untitled, is that it allows the 3 perspectives to be relatively independent of each other. Storage technology can change without affecting either the logical or the conceptual model. The table-column structure can change without affecting the conceptual model. In each case, of course, the structures must remain consistent with the other model. The table-column structure may be different from a direct translation of the entity classes and attributes, but it must ultimately carry out the objectives of the conceptual entity class structure. Early phases of many software development projects emphasize the design of a conceptual data model. Such a design can be detailed into a logical data model. In later stages, this model may be translated into physical data model. However, it is also possible to implement a conceptual model directly. History. One of the earliest pioneering works in modeling information systems was done by Young and Kent, who argued for a precise and abstract way of specifying the informational and time characteristics of a data processing problem. They wanted to create a notation that should enable the analyst to organize the problem around any piece of hardware. Their work was a first effort to create an abstract specification and invariant basis for designing different alternative implementations using different hardware components. A next step in his modeling was taken by CODASYL, an IT industry consortium formed in 1959, who essentially aimed at the same thing as Young and Kent. the development of a proper structure for machine-independent problem definition language at the system level of data processing. This led to the development of a specific as information algebra. In the 1960s, data modeling gained more significance with the initiation of the management information system concept. According to Leondes, during that time, the information system provided the data and information for management purposes. The first-generation database system, called Integrated Data Store, was designed by Charles Bachman at General Electric. Two famous database models, the Network Data Model and the Hierarchical Data Model, were proposed during this period of time. Towards the end of the 1960s, Edgar F. Codd worked out his theories of data arrangement, and proposed the relational model for database management based on first-order predicate logic. In the 1970s, entity relationship modeling emerged as a new type of conceptual data modeling, originally proposed in 1976 by Peter Chen. Entity relationship models were being used in the first stage of information system design during the requirements analysis to describe information needs or the type of information that is to be stored in a database. This technique can describe any ontology, i.e., an overview and classification of concepts and their relationships, for a certain area of interest. In the 1970s, G.M. Nijssen developed Natural Language Information Analysis method, and developed this in the 1980s in cooperation with Terry Halpin into object role modeling. Bill Kent, in his 1978 book Data and Reality, compared a data model to a map of a territory, emphasizing that in the real world, highways are not painted red, rivers don't have county lines running down the middle, and you can't see contour lines on a mountain. In contrast to other researchers who tried to create models that were mathematically clean and elegant, Kent emphasized the essential messiness of the real world, and the task of the data modeler to create order out of chaos without excessively distorting the truth. In the 1980s, according to Jan L. Harrington, the development of the object-oriented paradigm brought about a fundamental change in the way we look at data and the procedures that operate on data. Traditionally, data and procedures have been stored separately. The data and their relationship in a database, the procedures in an application program. Object orientation, however, combined an entity's procedure with its data. Types of data models. Database model. A database model is a specification describing how a database is structured and used. Several such models have been suggested. Common models include flat model. This may not strictly qualify as a data model. The flat model consists of a single, two-dimensional array of data elements, where all members of a given column are assumed to be similar values, and all members of a row are assumed to be related to one another. Hierarchical model. In this model, data is organized into a tree-like structure, implying a single upward link in each record to describe the nesting, and a sort field to keep the records in a particular order in each same-level list. Network model. This model organizes data using two fundamental constructs, called records and sets. Records contain fields, and sets define one-to-many relationships between records. One owner, many members. Relational model is a database model based on first-order predicate logic. Its core idea is to describe a database as a collection of predicates over a finite set of predicate variables, describing constraints on the possible values and combinations of values. Object relational model. Similar to a relational database model, but objects, classes and inheritance are directly supported in database schemas and in the query language. Star schema. The simplest style of data warehouse schema. The star schema consists of a few fact tables, referencing any number of dimension tables. The star schema is considered an important special case of the snowflake schema. Flat model, hierarchical model, network model, relational model, concept-oriented model, star schema. Data structure or diagram. A data structure diagram is a diagram and data model used to describe conceptual data models by providing graphical notations, which document entities and their relationships, and the constraints that bind them. The basic graphic elements of DSDs are boxes, representing entities, and arrows, representing relationships. Data structure diagrams are most useful for documenting complex data entities. Data structure or diagrams are an extension of the entity relationship model. In DSDs, attributes are specified inside the entity boxes rather than outside of them, while relationships are drawn as boxes composed of attributes which specify the constraints that bind entities together. The ER model, while robust, doesn't provide a way to specify the constraints between relationships, and becomes visually cumbersome when representing entities with several attributes. DSDs differ from the ER model in that the ER model focuses on the relationships between different entities, whereas DSDs focus on the relationships of the elements within an entity and enable users to fully see the links and relationships between each entity. There are several styles for representing data structure diagrams, with the notable difference in the manner of defining cardinality. The choices are between arrowheads, inverted arrowheads, or numerical representation of the cardinality. Entity relationship model. An entity relationship model, sometimes referred to as an entity relationship diagram, is an abstract conceptual data model used in software engineering to represent structured data. There are several notations used for ERMs. Geographic data model. A data model in geographic information systems is a mathematical construct for representing geographic objects or surfaces as data. For example, the vector data model represents geography as collections of points, lines, and polygons. The raster data model represents geography as cell matrices that store numeric values, and the triangulated irregular network data model represents geography as sets of contiguous, non-overlapping triangles. Groups relate to process of making a map. NGMDB data model applications. NGMDB databases link together, representing 3D map information. Generic data model. Generic data models are generalizations of conventional data models. They define standardized general relation types, together with the kinds of things that may be related by such a relation type. Generic data models are developed as an approach to solve some shortcomings of conventional data models. For example, different modelers usually produce different conventional data models of the same domain. This can lead to difficulty in bringing the models of different people together and is an obstacle for data exchange and data integration. Invariably, however, this difference is attributable to different levels of abstraction in the models and differences in the kinds of facts that can be instantiated. The modelers need to communicate and agree on certain elements which are to be rendered more concretely, in order to make the differences less significant. Semantic data model. A semantic data model in software engineering is a technique to define the meaning of data within the context of its interrelationships with other data. A semantic data model is an abstraction which defines how the stored symbols relate to the real world. A semantic data model is sometimes called a conceptual data model. The logical data structure of a database management system, whether hierarchical, network, or relational, cannot totally satisfy the requirements for a conceptual definition of data because it is limited in scope and biased toward the implementation strategy employed by the DBMS. Therefore, the need to define data from a conceptual view has led to the development of semantic data modeling techniques. that is, techniques to define the meaning of data within the context of its interrelationships with other data, as illustrated in the figure. The real world, in terms of resources, ideas, events, etc., are symbolically defined within physical data stores. A semantic data model is an abstraction which defines how the stored symbols relate to the real world. Thus, the model must be a true representation of the real world.